appreciate you being here, and Roy's going to take us through DealerTrack's journey with MuleSoft. You all set there on the mic?
I think so. Can I have a quick?
Yeah, good.
Good afternoon, everybody. My talk will be maybe a little more techy and focusing on operation side, but hopefully I won't bore you. So we will talk about specifically a package that we create. We call Fugu framework today. We want to share our experience on challenges we have faced, how we use MuleSoft to solve a problem, and I want to tap into how valuable MuleSoft consulting is for our project. So DealerTrack, F&I MuleSoft, we started using the product approximately 3 years ago. We've been using it heavily from the past 2 years. We're focusing on specific F&I, finance and insurance solutions. For all the loan processing, we have about 1,500 lenders and 20,000 dealerships using our software today. We process more than 1 million transactions every week. So with DealerTrack, I can blow it through, but be realistically, if you go online, you saw a car, an advertisement, you click on it, bring it to a dealer website, that's us, right? When a walk-in dealership, you want to buy a car, you pick a red color, but the dealer say, hey, they don't have it, they have the blue color. That's also us, behind the scenes. Dealer uses software to manage inventory. And when you go purchase a car, trying to get a loan, that's what we are, F&I part of it. So we have 1,500 banks hooked up in our network, so the dealership use our network to find a loan for you. And we recently just got bought out by Cox and Woolworth, and it's exciting. Now we are more than a $2 billion worth of company now. We're currently private, and I think we're close to $6 billion now as part of the Cox family. So what is our core strategy? Trying to connect all the Internet of Things, right? That's the buzzword IoT everybody uses these days. Is basically connecting platform within DealerTrack itself. There's a lot of individual solutions. Connecting our internal system or external partner and create synergy, and that's at the end when things are all connected, that becomes a competitive advantage. So just like everybody else going through the distributed computing evolutions, and from Cobra, LMI, and now we have SOAP and RESTful API, but it's just going through the same period, same kind of evolution like everybody else. But it's easy for everybody to write services, right? Everybody talk about, hey, I will have a services. Even my refrigerator someday will have a services at home, right? So it's easy to expose services. Everybody's going through standardizations, but going back to our F&I, the challenge will be we are creating transaction flow that will hit multiple service endpoints. And we need a simple way for us to define the workflow. We need this workflow to be visible and to be reliable. Think about you're making a lot of HTTP call over the internet, and not sometimes, I'm sure everybody, you write your code, you will have to retry a few times. But in our cases, connecting to 1,500 banks, there are times that they were down for hours. We cannot shut our door, right? We need to make sure that system continues to flow. So our challenge number one is not all protocol is the same, even they all REST, but it's slightly different. It's great that we have RAMO coming out. We will try to standardize with everybody, but to go through standardization with 1,500 banks, it will take a while, right? If you have custom header and format, it will probably take the bank a little while to change. Throughput also different, depending on the time frame. They could be very fast in the morning, but during rush hour, when on a Saturday afternoon where everybody going to buy cars, the system gets slower and slower to the point that it could be from 5 seconds to maybe 2 minutes to response. You can have different timeout settings, and endpoint could be down for an hour, and the bank will call you back and say, hey, our process is done, rewire to DR. I mean, we need that type of flexibility to change. That's our challenge number one. Challenge number two, like I said before, our transactions no longer basically hitting multiple endpoints. As in a Java driver, I'm sure everybody understands there's two-phase commit, right? You can go through one, everybody vote, then we go back, or if we all commit together. how many times do you actually hit a service that allows you to roll back your transactions? I mean, it's rare to have that. And also, we also need to be able to capture if I hit the first bus stop, the second bus stop, and be able to see what was captured, and the third bus stop could be done, and I need to persist from there and then retry from that point, right? It could take hours. You need to be able to see it, sometimes see what's going on. And challenge number 3, we learned it from the last 2 years, ESP is a black box. A lot of time when the upstream portal goes to your device, submit an order saying to the ESP, we respond back, it becomes an asynchronized transactions, but many times behind the scenes you're doing all the hard work and there could be all error coming out, and but the upstream will expect everything to be successful. It's really a fairy tale, it doesn't happen that way. And if you need to look at an error, you have to look at log files, go into Splunk and try to retrace everything back together. It takes forever, or you can move the message to a dead letter queue. And but I don't know how many of you here remember last time the dead letter queue overflowed. I see some people smiling, right? And that is a challenge. So lesson learned. We need to persist all the transaction state, record all the endpoint conversations, how fast you respond, what do you send it back to me, right? And then if I fail, I want to continue where it last failed. We need to be able to switch on and off to endpoint. Literally, partner could tell you on a Sunday afternoon, we have a maintenance window, we're not available for business. But we still have dealer submitting app, the poor guy probably working on dealership on Sunday morning, submitting apps, submitting loan applications, and we still want to capture that. And we also don't want to overload some of these endpoints. It means they could only take 5 apps at a time, 5 connections, but you open the 6th one to them, they could choke. We also need a dashboard to tell us what's going on, to be able to manage transactions and literally say, hey, who's down, who's up, how fast they're going through. So we developed a framework called Fugu. Fugu is basically the blowfish. It's a Japanese sushi, so you can prepare it right. It's deadly. So we went on that mission for a year, went on the ground, go on the radar, found a room that's no window. Turn on the light, just cook it all day long, try it. We developed this package using Mule because we love Mule because there's so many connectors available and it's really easy to use. We want to develop a framework that allows developers to focus on the business flow. All right, focus on which endpoint you need to hit, but you don't have to focus on the retry resiliency level curve because it's the same curve. You're dealing with HT endpoint, it's pretty much considered the same, but you have different thresholds to tune it. We want an administration team and a NOC team to be able to see what's going on and just, if the partner's down, call them immediately. We want the system to be agile and you can configure in runtime. At the end, it's more important, reliable and resilient, right? Self-recover when their connectivity down, and if they're done, we want to slow down the traffic and we'll push it over when they reconnect. So this is a high-level picture of how the component looks like. On the left side, this is where the developer will focus on how the business orchestration will be. And on the right side, we have something called, this is where the Fugu framework came in. We have something called circuit breaker, gateway. On the right side, you get internal on all the external endpoints. For all the transaction flow, we journal it in Mongo database, right? And we also have a dashboard and transaction service allow them to reprocess transactions if they need to and do the reporting. So how does it work? Circuit breaker, I'm sure we all have it at home. You push it down, there's no power. You push it on, there will be power. So circuit breakers automatically create representing each HT endpoint. You can also have throttle control. So if they can only handle 5 connections, don't give them 6, because you're wasting your network resource and you got have blow up smokes on the other end. You also have a retry back off logic, so things, if they are not available, we don't want to keep knocking on the door, so we queue the request, but we will continue to go slowly from 2 seconds, 4 seconds, 8 seconds, 16. You can configure it one time, but still knock on the door, kind of doing a heartbeat, but when they up, and we flood everything over. We also have the URL override. If you're doing business with the other partner system, they will tell you that really process that, change to another location, give you an IP. We can also do that here. So override what's inside in your code. The layer, the second layer is called gateway. So what is used is to translate. A lot of RESTful endpoint probably the same, but there are a few occasions there may be a 20% that speak differently. The way they define REST is not what everyone else is. So we want to treat them, give them opportunity to create a layer that we can translate those protocol with those endpoints. And the gate will also determine if this is a retriable error or non-retriable error. If from me back XP 500, may not be retriable. But if I'm getting a socket timeout, that should be retried. We also help to record all the conversations and the time history, and we put it all into the journal. This is the part where the journal are. We record the journal, the conversation history, transaction state. If I need to push my flow from service A to D, but if I'm stuck in C, you will be able to see here. You will be able to see how many times it's being retried, and you can. It's also maintain the order, which transaction came in first and which one second. So we will go through transactions in order when it recovered. The last part, this is the money. Because we do all the hardware, all the framework, nobody see what's the value. But when we brought this field screen to, literally this is the cheapest part. We spend the least amount of time working on this, probably a month. We spent 3 weeks, build a very, very quick transaction portal that they can actually manage transactions. They can search and look up the transactions. And we also create a screen called circuit breaker screen, tell them what's working, what's not working, what is scheduled to have a downtime. It makes a huge difference. Guys actually see, which endpoint is up and down. And so we evolve from there. We start integrating our solution with Splunk. The one in the back is actually what the NOC, the network operating center, will be. It's watching today, on and off, and also set up alerts. So it's very simple. Green is good, red is bad, and because they have so many dashboards to look at. It's like a NASA's operating center. We just walk in, they see red, they will start looking into it. And then the one in the front, the dashboard in the front in Splunk is give you the overall response time, throughput, volume. This is great for business operation team. They can actually do a lot of analysis and figure out what is good and bad. This is the part that we didn't expect as a huge value when we work on this framework, just by able someone to see and gather statistics. So this project is called Fugu framework. We'll try to open source this in this year. I think it's great that there's API portal managing API, but for us, we're kind of on the other side. We're consuming all these API from 2,000 different endpoints. They are in different varieties. So I figured there probably other people have the same challenges. And this is the part that I think is key. So while we're working on this project, we engage MuleSoft Consulting 4 times. Every time the money is well spent. In the inception stage, when we try to work on this framework, we have MuleSoft come into validate our concept, showcase new idea and capability. They're on the bleeding edge, they know what's coming, what is proven working with other clients, what is kind of like, great, but there's a drawback, what use it as your own risk. We identify those areas. Then the second stage, when we design this framework, we have also MuleSoft come in and refine our design. Some blue probe type thing together, bang out something that's really usable, what's not usable. At the development stage, in the midpoint, we also engage MuleSoft come in, review our code, give us a scorecard for the code. And then at the end, when we go in productions, and they came in and tuned the system, not just the flow, but all the connectivity with the databases, how this endpoint will be used. They tune the whole stack for us together over 3 days. And I believe you have the right tools, you have the right ideas. I think also you need to have the right guidance, because the tool could be so powerful we don't know how to use it. I think that's it for I have.